Hey everyone, and welcome. Today we're going to break down one of the most useful ideas in all of math, and that is surface area.
You know the feeling, right? You're wrapping a gift, it's going great, and then you hit that last side and realize you're just a little bit short on paper. It's the worst. But believe it or not, that is a surface area problem.
Yep, the key to solving that whole wrapping paper mess is understanding surface area. And here's the thing. The secret to getting this stuff right isn't about memorizing a bunch of crazy formulas. It's way, way simpler. It's all about seeing the blueprint.
So, how do we actually see this blueprint? Well, it turns out there's a kind of secret weapon we can use, something called the net.
A net is just, well, it's what you get when you take a 3D shape, cut it along its edges, and lay it out flat. Just imagine a cardboard box. If you cut the tape and unfolded it completely, that flat piece of cardboard on the floor, that's the box's net.
Let's make this super clear. Just picture a simple, perfect cube in your head. 6 square sides, all exactly the same.
Okay, now imagine you have a tiny pair of scissors, and you start snipping along just enough of those edges so you can unfold it.
And as you flatten it out, what do you get? You get that classic cross shape, right? A shape made of 6 squares all connected. And that is the blueprint. That is the net. Honestly, if you can picture this in your mind, you're already halfway to solving any surface area problem.
All right, but before we jump into the numbers, there's one quick but really important distinction we need to make. Are we talking about some of the surfaces, or are we talking about the whole shebang?
And it's actually pretty intuitive. On one hand, you've got lateral area. Think of this like painting the walls of a room. You're not going to paint the floor or the ceiling, right? Just the sides. Then you've got total surface area. And that's our wrapping paper problem. You have to cover every single surface, the top, the bottom, all of it.
Okay, you ready for this? Because this right here is the single most important idea we're going to talk about. This is the one simple strategy that makes all those intimidating formulas pretty much useless. That is it. Seriously, that's the whole secret. Forget trying to memorize 2 times length width plus 2 times length height. No, just look at the shape's blueprint, its net, and find the area of each little piece. Then add them all up. If you can find the area of a rectangle and add, you can do this. I know what you might be thinking. No way. It can't be that simple. But it is. So you know what? Let's just prove it. Let's do one right now. Okay, we're going to find the total surface area of a basic rectangular box, like a shoebox or something you'd get in the mail.
So let's give our box some dimensions. We'll say it's 2 units high, 3 units wide, and 4 units long. Got that? Height is 2, width is 3, length is 4.
All right, here's our game plan. We're just going to follow that one rule. We'll figure out the area for the top and bottom, then the front and back, then the left and right sides. And once we have those 3 numbers, we just add them together. Simple.
Okay, first up, the top and bottom. So their dimensions are the width and the length, right? That's 3 times 4, which gives us 12. But remember, there's a top and a bottom, so we've got 2 of them. So that's a total of 24 for that pair.
Great. Next, let's do the front and back. Those dimensions are the width, which is 3, and the height, which is 2. So 3 times 2 is 6. And again, there's 2 of them, a front and a back, so that's a total of 12 for that pair.
And last but not least, the left and right sides. Those dimensions are the length, which is 4, and the height, which is 2. So 4 times 2 is 8. We've got 2 of those sides, so that gives us a total of 16. Okay, that's it. We have the area for all 6 faces.
So let's recap what we've got. We have 24 for the top and bottom, we have 12 for the front and back, and we have 16 for the left and right. All that's left to do now is just add them all up.
And when we do that, we get 52 square units. That's our answer. That's the total surface area.
See what we did there? Or rather, what we didn't do. No fancy formula, no weird letters. We just pictured the blueprint, found the area of the different rectangles, and added them up. It's just logic, and it works every single time.
So that's the real takeaway here. The most important skill isn't memorizing formulas, it's about being able to see that blueprint in your mind. If you can mentally unfold an object and see its net, you've totally got this.
And that kind of leaves us with a fun little puzzle to think about. Unfolding a box is one thing, because it's all flat sides. But what about something with curves? What would the blueprint, the net, of a soup can actually look like? Something to chew on.